is what I'm excited about. As much as, you know, interviewing Doug Yates is cool, I want to get in, you know, almost hands-on and talk about balancing an engine. So let's start off where we left off with the ISO standards.
Sure. Okay, listen. The ISO is actually 21940. That's the registered number. So what I'm going to do is show you on the computer here. We're going to go in and we're going to ask the machine to come up and give us the ISO calculator. We built this on all machines, and the nice thing about this standard here is it's global. All right, so again, what I'm going to do, this is set up, and I'm going to use pounds because we're here domestic. And then we have a quality grade here of 6.3. But the next thing it's going to ask me for, what is this mass weight? Now, the guy says, how do I know? Well, bathroom scale works, so you know I have to get carry weight. So I'm going to come back here and I'm going to make this unit at 89 pounds just to show you a quick reference. The next question we need to know about it is how fast are we going to rotate? We call it the critical speed. So let's pick this thing out and let's have a little fun with this. And I'm going to say 7,500 RPM. Now, when we do this, the next thing it's going to ask for is a reference. In other words, ounce inch is here what we do domestic. So it's saying the tolerance will be 0.225, or to get this in perspective, at the radius of correction, which in this case 3.73, I want 1.7 and 1.7 on each end. Now there's another reference we're going to get to in just a second, but I want you to understand there was a question, should I cut this in half? You know, where's the net benefit of that? I use the term entertainment. One of the reasons I use that is that you have to understand this crank is not spinning on center. It is actually a situation where it's revolving. I have a lot of fun with this when I talk to customers and say, well, how can it revolve? Well, you do know there's clearance there. You got bearing, bore, crankshaft itself, and oil. The interesting part about this is through the mechanical action of rotation, what actually happens is this thing is orbiting and it gets down to just a couple tenths of a thousandth on one side, which means if I had 2,000, I got 1.8 on the other. So what I'm exaggerating this, but here's what you're doing. Not spinning on center, you're doing this. Now, when you do that, when you go into orbit, this is basically saying if you hit this tolerance, you're good. The standard understands that this is not a perfect world with a perfect center line. Now, one other thing that we want to do with this, I'm going to say, do I want to apply it to this job? It embedded it into the program, and then I come back and I save it so that it's gone into a histogram. Now, this thing will hold 2 million applications. It's really pretty powerful. And just for the sake of argument, I'm going to show you, I have a will call up here, and I've got all these jobs in there. So I want to just come in and say, look, how do I find it? I'm going to say 4, and you see how it started selecting 5, and there it is, 454. It's going to load. So the mental gymnastics is one of the key applications of our machines, and that you don't need to know this thing. You see how quickly I got there? This is key. All right, so does that help you with your standard?
Absolutely.
Okay.
Absolutely. And it just also helps me to think about how rapidly you're able to bring up the vital information, which brings us back to where we've been talking the whole time about technology advancing, whereas John was looking to reduce parasitic loss inside the crankcase. We've reduced some parasitic loss out here in getting the job done.
Let's talk about that for a second. When you're in unbalance, what people clearly do not understand is, and I'm going to go back a couple decades, if you would weigh the block that your engine is, you notice everything that's built now is new, lighter, thinner. Now, yeah, they got structure ribs, I get it, but they're very, very excitable. In other words, one of the things, and I'll go back 2 decades, this same crankshaft, it was balanced by OE that sent it down the road, it'd be 2 ounce inch. Now, we're at 0.2, okay? Well, just for what it's worth, 2 decades ago, that was a racing standard. Right now, it's an OEM standard. Now, why'd they do that? They did that because everything is resonating, it's easily excitable. So what happens is we have electronic components assigned to the engine. The CAFE standard said we get better gas mileage. So the ECI, ECUs, whatever you're going to have there, are controlling the mixture, the feed. So when this sees a knock, it says, hey, I got pre-ignition or I'm lean, so it fattens the motor up. What do you think mileage does? In the toilet, right? So what the OEs have learned is that this is the exciter right here. That 2 ounce inch under a light duty base chassis, or in this case engine, gives false triggers. So it's critical that we come back in the first order and get to this standard. Now, like I say, this used to be racing standards. This is OEM now. Grandma's car is balanced there, right?
And racing standard now?
Racing standard is there and below.
Excellent.
All right?
Excellent. Well, I know we're going to do a demonstration. We did just get another question to follow up, if you don't mind.
Sure.
Just about, does the CWT do a conversion based on diameter and depth on the heavy metal or tungsten?
Well, okay, well, we can jump to that real quick here, because what we'll do is I'm just going to go ahead and populate this. I'm going to give it a target RPM. In this case, we'll do 500. We're going to launch. Now, notice we do have the safety shield away, and Joe's going to be very kind not to get injured here.
Yes.
I hate the sight of blood.
I do too.
Right. So what we're going to do is we're going to draw in data. You can see it's analyzing. Now, it's going to shut down in just a second, and it's going to populate up here. In this particular example, what we've got, and I'm going to bring it up here very quickly, right to top dead center. Now, you're going to notice top dead center is in alignment with the crank, right? Wait a minute. I can't drill it. I got air. I got a problem. So we can quickly jump over here, and I can go ahead and let the computer know I'm in an add situation. Well, let's go ahead and see where it wants to add. We got the same problem. We hit air. All right, we have a remedy here. It's called heavy metal vector. So what I'm going to show you is I'm going to let the unit know exactly where that counterweight is. I'm going to let it draw up. Now, interesting enough, you're going to see here, this is the counterweight. This is where I want corrections. It's no man's land. Now, normally you start panicking. What I do is I just hit a spot. Now, I let the computer go in and try to resolve this. The first thing it did is I'm going to put a slug here, and notice this green-yellow light is saying this is going to be the new load moment. And that's really what I want to do. Now, if I move that, I change the weight, but you see I've got it more in the center, and I want to know what that is. And very quickly it says 875 slug, 1.2 wide, and all I have to do is roll around, line that up, and I come right through the side right there to fix this. The mental gymnastics that we used to do in the old days, the old Struhl Warner days, the old Heinz days, that's old school, right? I don't need to know. And in fact, I now can call the customer up and tell him exactly what it's going to cost. No guesswork. So the customer's either going to say yay or nay right away. But if I go and start drilling holes or making chips, or in this case, putting heavy metal in, I own it. So I'm just giving them a Pac-Man game to get solution. Okay?
Love it. All right, let's walk through the process and generate some data.
All right, let's do this now. We're right back to Virgin Estate, and so what I'm going to do is I'll first put it over here, and I'm going to show you what happens on this particular crank. I've had a TDC, and again, it created a problem. Well, what do I have on this side? Well, I come back up to TDC right here. Now, you can see here, I can throw heavy metal right there right away. But one of the concerns that we have is that when I come in and I look at what we consider the static and the left and right planes, see this right here is telling me I've got 24 grams of unbalance. I got 24 grams of unbalance. I got 114 in the middle. So you see, by it being out of vector, it's created a load problem right here in the middle of the crank. So by us working through this, I can come up with solutions, and what we ideally would want to come up to is tolerance on this side, and by the way, tolerance here, right? So it's important that you understand, if you look at the crank, you see the counterweight, and I'm going to call it north, and I look at the other one south, it's important that we end up with a situation where we draw just like this, and we have zero load in the center, zero, and we also call that static. But the key here is that we can give quick remedies on how to process, and I can make scenario after scenario without making the chip. That's critical.
Very, very interesting. And we just went through how important balancing is to make everything live and survive, the engine process. So have we already gone through? We basically generated the data on this piece. How much effort and time goes into getting it right, like everything you just described?
Well, I have a lot of fun with that because at our facility, we're fast. That's bottom line. In fact, I joke about it. I say on normal situations of balancing, if it takes more than an hour for us to do the process, that's called a career move in my shop. This guy has a new job. So, but the way you can be fast at it is two things. Input is valid, correction is actually dictated, and then everything else that's related to this unit, we can handle everything without getting out of the work zone. It's very important. If I go from here to there, I know me well enough that I'm going to change my thought process. Well, stay focused and get the job done.
Exactly. So what other benefits to the machine, other than clearly the technology and the ease of use and touchscreen, but I can see like it's set up to be very ergonomic, I guess is the best way to say it.
That's exactly right. So once we have a plotted solution here, we will introduce it to this stand. We'll merely move over into position. This is an not an R8, which is what typical units are. This is an ER40. Same thing you're seeing in these roller machines. Now, the advantage of that is that we have a much broader base of tooling selections, and it's much more rigid. For instance, instead of a half-inch support, we can go all the way up to a 1-inch collet, right? And doing so, when I'm coming in and I'm boring and reaming, I can sit there and make sure that my concentricity is maintained. I talked earlier in a video about the fact that I see people do slip fit application. They'll come around and they'll weld. Look, that's just old and it's bad, and it should never, ever be done, right? The guy who sits there that purposely comes in, I'm going to reintroduce this one more time, that does it radial like this. In other words, we'll see situations where they'll come in and they'll pop holes like this and put the slug in. Now, of all things, they'll actually take a freeze plug and weld it. Now, a galvanized freeze plug, first of all, you just set up hydrogen embrittlement, right? That's the first thing. So you've delayed the launch, but when that bullet comes out, and you know what a 9mm is shooting? Think of a 1-inch, right? 25mm bullet coming out of there. It's going to leave a mark that you can't wash off.
Yeah, I can't believe that happens.
Oh, there is an old saying, and you can't fix stupid, right? And it's a pretty harsh statement, but that's stupid to do anything like that. That's suicidal, right? And the way I always tell this story is important that you understand the severity of that. This is an engine. You're driving down the road, and it lets go. It goes right through the pan, throws oil on the ground, cuts the tire down, car loses control, and hits the bus that has your grandchild in it. Did I get your attention on that one?
Yeah.
All right. You got to understand, this is it's just an accident waiting for a place to happen. Don't do that. The other side of it, I want to go back to one other thing. When we drill excessively into the counterweights, that's a giant no-no. When this counterweight starts to flutter, all right, remember this mission statement is not just to correct the amount of mass here on the crank journal. It's also, believe it or not, a torsional control mechanism, right? When these units become excited because you've drilled holes and are so close, they start doing this. They flutter. Now what happens is knee bone connected to shin bone, so this goes off to the timing chain goes up cam gets excited, life is bad, right? Anytime that you take a rotating mass and you turn it into, quite frankly, a shaker, everything's going to respond to it. So you're going to disrupt the primary design of the engine. For instance, John Calley is just a genius, and he comes up with all these different things, but he understood right away the importance of this having functionality and to attack parasitic loss. Well, parasitic loss is the target, but if you have excitation, where this unit has become excited, you'll see that everything hooked to, remember, you got a light block. It no longer dampens. It's going to sit there and become excited also. If you want to have even more fun, you're going to see distortion of the bores. You're going to the entire engine is becoming traumatized by vibration. Fix this first, take that variable out of the equation, then all of a sudden all these other cool things that we're doing in industry, everything that we're spending so much time on, borings, getting cylinder geometry, surface finishes, all that, it works. If I take this thing and I create this, someone just beating it with a hammer, just think of that while it's running. You can see the thing, where's it? It's going to happen. They're not going to like what we see. I need to grab one more thing here while we're talking. I'll be right back.
Absolutely. He'll be right back. I think about, balance good, karate good, balance bad. Well, it applies to engines as well. You got to have the balance.
Let me have a little fun with you. We put this in the same scenario. In the old days, and I'm going to go back 20 years ago, I used to have people argue with me quite a bit about balancing camshafts. And I'm in somewhat agreement with them. Because some of these things were like giant spindly shafts. Waste of time to balance it. But now this guy, it's a little bit different, right? This is where we're starting to go into the Pro Series. And you can see his multiple load. But here's, I don't know if you can zoom in on that or not. What we're doing is we're adding weights to the cam so that we can now use it. Because if I have to remove metal, I'm not going to take it off a lobe. I'm going to sit there and work with this attachment. The other end of it, I'm going to have the timing gear. So we now can introduce it to the balance machine and balance these things and take the vibration out. The other side of it is, this is an old one. this is something, you know, I'm not going to say where it came from. I'm just going to simply say that we're now doing 82 millimeter sizes. These cams have gotten stronger, and so they need to be balanced. And one other thing, this bad boy, let's take it up to 10,000 watt this guy, 5,000. Hey, this thing has influence. It needs to be balanced.
Very, very interesting. Now, earlier we got a question about the flex plate and the balancer being on when balancing. You described it before, but let's go rehash that, because we've got to get the crank right first.
Okay. In an internal balance situation, where we have a situation where, again, everybody understands internal, the crankshaft itself is its own identity. We balance it to tolerance. Then we add the harmonic balancer and the flywheel, and we consider that the offending mass. The chances of it being perfect, 0, right? 0. So let's just say this is out 5 grams, this is out 12 grams. Do I correct the crank? The answer is no. You do not correct the crank. What you should do is only correct the offending mass areas. Now let's flip that coin for a minute to external. External, we're going to have a counterweighted event here and a counterweighted event here. Guess what? We don't adjust them. We only do the crank. So you see the difference, a reverse order? If I go in and I make these two units supposedly offset to a specific amount, I can have them explode and go away and get sisters to it, put it back on. If I put these on and I correct here, I've created a total marriage. And I think the statistical marriages and failures is pretty high. Okay?
Nice reference.
All right, so I'm hoping that answers your question here.
It does.
Okay.
It does. All right, so we've gone through a lot of data right there, and this is an area that is significant and important. The machine is very cool, judging by the response we've gotten, very positive. Is there anything else that we would like people to know as they go down this road?
Sure. I referenced several times the ISO standard. What people don't seem to understand, if I allow any imbalance to stay in this crank and I put this engine together and it has a vibration. Now, I can have a running situation where I lose an injector, for instance, and I'm going to be out of balance. I can lose a spark plug or something like that. I can replace those and I can fix things. Balance, you don't get a second shot at this gig. Once you put it in, it's like a little baby with a little hammer left alone. It's going to sit there and wear you out, and it's just going to beat this thing apart.
Baby with a hammer.
Baby with a hammer.
You got a lot of great analogies, but the foundation is that this has got to be right. Simple as that. Like, you've got to get this part right if you want your engine to live, which we all do.
We have evolved at this point. I said it earlier in the presentation. What we did 5 years ago, a year ago, even 5 months ago, has changed, and it's a removing target. You have to take this seriously, because anything that you leave in a damaging event where it is causing chaos or it is an exciter, you can't get rid of it unless you take it all apart. So what I think is important is that people are overlooking this one single thing about balancing, and we're going to understand that pay attention here first, and given the fact that all of our stuff late model, the alloys have changed, the mass weights have changed, and if we intentionally put a device in there to disrupt the functionality of the rest of that engine, shame on you. You missed an opportunity to take a variable out of the equation and run with constants. That's what the new way to build engines is. Get rid of those variables.
Very interesting. I see the bob weights, of course, as you described a little bit earlier.
Let's talk about that one more time, because this is critical to the equation. I go into shops and I see guys that they're great people. They're claiming they're doing excellent work, and I'm not trying to demean them in any way, other than the fact I'll see their bob weights. They've drop tested it, they've ground on them, they've got them distorted. This is the equivalent of a micrometer. The accuracy of this is critical to the application. If I sit there and I ding it, right, the moment center will shift. And if that happens, what will happen is you get false input. And remember, you have to respond off this data. If you don't respond to data correctly, in other words, it says 24, but it was really 38, and you make that correction, the machine doesn't know that you have a faulted tool. It responds just like a newborn baby again. It believes that you got it right.
And so now we're making a very good point, just in terms of like maintenance of your tools. You mentioned the micrometer. Guys are like putting them on pillows and carrying them around in a protected environment. in this environment, maybe people don't realize they need to keep it as secure as you just suggested.
Exactly. Look, I'm the #1 supplier of bob weights in the world. Everything from locomotives, ships, all the way down to little motorcycles. The advantage that we stress is that this is the unit that basically takes the total weight of the piston rod assembly, and if it is not true and accurate, everything you get here is corrupt. Now, when you treat this with a certain amount of you're cavalier in your activity, and then you're proclaiming that you're doing it right, we got a problem. Now, we just need to understand that these things are critical to application. If your bob weights are dinged or beat up, we can maybe fix them, but in most cases they have to be replaced. Okay?
Good information. So what about the person out there who is receiving this information and they're saying, all right, I'm doing it wrong?
Right.
Training, all of that, where does that come in with the machine? If you bring you guys in and you decide you're going to do that, how does a person who has been doing it a different way, an older way, a way that maybe is from a day gone by, catch up and get up to speed?
All right, two things. We, again, are the only U.S. facility that has a bona fide curriculum on training, all right, #1. But more importantly, we have the facility for that. So when you come to us, not only do you get to learn about it, you get to see how we build them, right? That's rather important, because what we really find is our relationship with the end user is critical. We just call them friends now, not customers. It's important that they know they can call me anytime. Look, our resources and application on this are second to none. We are willing to share that. We never, in fact, we spend more time correcting a process to make sure that they're doing it right, regardless of our machine, whether it's ours or theirs. We'll help them out.
Excellent. Great customer service, and I know that that's important to a lot of people. They want to be able to connect.
One last thing.
Yes.
I have machines all over the world. In fact, they're in 59 countries. I can run any machine that I have off my cell phone. Now, what that means is I can come in literally, tack, look, and I can sit there and ping the electronics, and that's what I'm doing right now. I'm challenging all my electronics to find out if they're working properly. I can do that in nanoseconds. The old days, calling up a rep and telling them to come out, go on. Again, this is not your father's Oldsmobile. But see, I can pick up these signals, and this is like an EKG system. We know whether it's functioning. Now, if you still have a problem, we realize it's procedural related. Well, guess what? Let's have a conversation on how you're doing this. But I will run their machine from where I stand, regardless of where I am.
Even on the beach.
Especially on the beach.
Well, excellent stuff. CWT Industries, of course, you can find out more information out there on the web. We're going to have question and answers coming up, so definitely stick around. Randy, this has been fantastic, and knowing the significance, the importance that this plays in the building of high-performance racing engines, we've learned a lot. Thank you very much.
Thank you, Joe, and I appreciate the opportunity to work with you.
Oh, it's been great, and it's just getting started. We've got more Engine Performance Expo constantly coming up. Everybody, hang in there. We've got question and answer. It's all coming up. Stay here right now. All right, question and answer. Here we go. We are working on some questions. Okay, first of all, someone had asked, is the Rottler guy coming back eventually? And the answer is throughout the week. Of course, we're going to have that. If you do have questions about the machine, by all means, now is the time. So what we're going to do is we're going to open up to some questions and answers, and hopefully people out there want to know about the machine and how we can use it. Maybe some questions that I didn't cover initially will be asked from some of our audience members. But let's dive in as they begin to send them in and we read them out. The initial setup process that got us that initial data.
Well, as we actually load, what we're really looking for are what we call the eyes of the system. Let me go ahead and get back here. Where you see the green, we call them the cat eyes. What we have to know is what we call the distance of support. We call this B2B. That's not a drink, by the way. It's a deal where we know the bearing to bearing. The second thing we do is we want to input the radius. Now, what's cool about this, for instance, I'm just going to go back in my library, and I'm going to go to will call, and I'm going to say, let's see if we got anything in U, nothing found. E, let's back up. Okay, and let's go 4. All right. So I'm going to go up here and I'm going to pick a 351 Cleveland.
Okay.
And what it did is it went through the memory and it pulled up all my data. So this is the eyes of the system. I mean, it's just that quick to go from job to job. So again, we could sit there and measure it all every time. That's old school. Time is money. So what we want to do is if we have our library built in there, cut to the chase, call over a similar job, and we're ready to rock and roll. Now this particular one, if I use this data on this crank, I would get false input, right? So in this particular case, I'm just going to be very quick about it. I'm going to come back, the will call, I'm going to go 4 or 5, there it is, and I'm assume that all my data is true, and we're ready to rock and roll.
Excellent.
The only thing I really have to do, I should have mentioned that, is once I call up the program, I just need to go ahead and give it a target RPM and launch. Now, one of the other side of these things is that it's important that the data is repeatable, right? Now, I don't know if you recall where we started with this thing, but we're going to pull the data back up, and you're going to see it's exactly the same. Nothing changed, right? So I went ahead and I downloaded a different program, I put it back up, and it's come right back, and it's telling me exactly the same thing. Right there is what we want to remove, and you see that's a problem. Okay? So here's the deal. Every time that we actually put an application, the machine doesn't know it's a Chevy, a Ford, a Chrysler. It's a rotor. So they all have their personalities, by the way. Now, some of the aftermarket guys, what they really do is they take the genericacy of the shape, and they have no idea what the bob weight is, right? So the vendor will collect it, send it out. The end user is at right on the balance. The fact of the matter is, we go ahead and look at the fine print, they'll say plus or minus 2%. I gotta tell you, 2%, let's just go back here and look at the bob weight for a minute. We don't have the data on that one, hold on. Let's go to this one here. Let me just pull up one I know that we have in the library.
Keep those questions coming.
And I'll just pull up this one. I'll go back to bob weight. Now this particular one has been populated with data, but plus or minus 2%. I'm just gonna give you an example here. 1810, right? I'm going to go up here and put 2% factor on that. That now says 1841. That's a 30-gram shift. Now remember, our tolerance was 1.7. So when you start giving these arbitrarily overbalance, underbalance issues, this is what that really means. You're attacking the system by having a new load moment, in this case 30 grams more, and you're saying that's the target. The machine believes you. You correct it. Bad idea when it gets going into the engine.
Very interesting. Now, earlier we had some questions about software updates for older machines.
Yeah.
And how does that all work?
Well, it's very simple. The technology is such that we simply sign into you, and typically we'll use TeamViewer. That's a pretty common deal. We recognize your system. We're going to sit there and then download overnight. We're going to send a little message in the morning, say, good morning, you've been updated. And if you're a first-tier customer and over purchase from it, no charge. If you're not, it's going to recognize that right away, and then there's going to be a new message on it saying, good morning. Guess what you get to do? And that is you get to pay us for the update. That's just the way it is with anybody that's second tier. You buy a used machine, whatever. Nice for you, but remember the guy who honored us for business first time, he enjoys all the benefits.
Well, absolutely. I mean, that makes perfect sense that if you are new to the machine, get a used car, you don't get the factory warranty.
Exactly.
That's just a different deal. We started out talking about those ISO standards.
Yeah.
And how significant. There were a couple of questions about, overdoing it, basically, cutting them in half.
Entertainment.
And when you say entertainment, you mean unnecessary.
That's right. Yeah. I'm trying to be, I guess, a humorous. The fact of the matter is, you can polish. Let me change that. I'm going to simply say you can go over center with what you're doing with no net benefit. Now, if you have a lot of time to waste and you want to grow old not making money, knock yourself out. Or focus on the application. It's in tolerance, you've done it correctly, make your money, move on.
Does the end usage of the engine have a correlation with anything you're doing here within racing?
Well, racing is a critical part of it. That's why when we set the standard up, you hit that standard. But I want to reiterate that it's important that we set these up so we have a checking event of this is a load moment, go in this direction. This one here needs to be 180 degrees. So what it does is it just comes in just like this. There's no load here. Now, sometimes we just call that static, right? In other words, if I just let it free spin and that's zero, this thing you can stop it anywhere you want, even though out here on the end it has unbalance. Right? we really want to make sure that this is, the proper name for this is called coupled. We want to make sure TDC and BDC are 180 apart, right?
Very interesting. All right, if you guys got questions, you can put them up in the comment section for Mr. Randy Neal. And Randy, the machine is very impressive, and obviously I know we've worked together in the past, CWT Industries, and the machines are very popular out there. Any anecdotes or stories, without mentioning specific customers, because we know, but you think about all the racing that happens and how valuable this process is, you definitely have got some experience with what has gone on. Maybe extreme applications, something that put the system to the test.
All right, let me go ahead and actually run out for a second and talk about really big inch motors. Right? I'll tell you a quick story. We have a guy who came back and they said, look, we're on 47%. And I said, well, how'd you get there? He said, well, we just did this, we did that. And I said, well, why not 46? He said, oh, no, it goes to hell in a handbasket then. I said, are you kidding me? And you're 46, you're on the cliff and you're looking over the edge. I said, you're looking into the abyss. So why not come back to my side of the equation at 50? Well, we're looking at the bearing problem. What we're really finding is that people are misreading the bearings. They think they're misinterpreting what the load is on the bearing by a destructive force. What happens is these guys typically have a lot of clearance, 6,000 to 7,000 of clearance on the journals. What actually happens there, remember I told you the crank orbits?
Yes.
What happens is it generates a froth. Now there's an air bubbles, a series of them, and then it gets loaded. It's just like an ultrasonic cleaner. It goes in and creates a concussion event that will take the facing of the bearing and disintegrate it. They're misreading the bearing. They don't seem to understand that without that kind of elimination of this aeration, you're guaranteed that you made a new sonic cleaner on the bearing, and they will explode. We have a lot of evidence. I'll be glad to share it with people. They come back then and say, well, the problem is we have to run that because we're getting bearing swiping on the edge. That simply is caused by the fact that you exceeded the structural ability of the crankshaft. In other words, you got more load than you do integrity. So they say, I got to have one or the other. Well, okay, fine. If you open them up, understand there's a penalty phase. And that is you're going to misread, you're going to destroy the bearing. So I know I'm going to have some conflict with that, but I would just ask for the other way, come back with raw data that's bona fide with math, and I'll listen. So far, nobody has given me a reason to move off 50%. Nobody.
Very interesting. And you mentioned big cubic inches, higher RPMs. There's different, I think about engine competition eliminator. I think about some of the NASCAR stuff, things that spin, maybe not NASCAR anymore, but balance is balance, regardless.
Look, in the old days, we used to look at 5,000 as being a pretty fast spinning engine, right? Yes. Now we're sitting at 10,000 RPM. Now the forces of unbalance have increased fourfold then, okay? Now that's just a lot more stress. The cylinder pressure is causing the crank to literally become a flex rotor. That's what they're seeing in some of this bearing swipe. They literally have exceeded more power, and I'll use top fuel as an example. Listen, every run, they're changing one half of the bearing set. It's just beat that thing to pulp. And then I take guys that are running higher RPMs, and then again, they're nitrous base or they're, well, let's just say they have power adders, right? Sure. I like nitrous because it's so volatile. And what happens is they build an engine making X power here, and then all of a sudden they put more power here, and the bearing's saying, ow. It's just that simple. It's just not standing up. That is because you've exceeded the load of the crank. Now, the guy said, how do you fix that? Change the alloy, change the heat treat, change the radius. All those things are part of the equation. But balance is not the cure.
Excellent. Final opportunity for questions about the machine. Obviously, Randy's got your answers. Put them in the comments section. We would appreciate that. We got so much more to come here at the Engine Performance Expo. It's funny that you mentioned Top Fuel, my area of appreciation. Certainly, it's a miracle that those things even survive at all, let alone go down the track as well as they do, as quick as they do. And the core process is the same. You have to start out with a balanced rotating assembly.
Well, here's the funny part of what you just said. Sometimes they go down the track, right?
It's a miracle.
Oh, yeah. And in fact, it is a miracle when they get down there. I've been privileged to know these guys for years and years. In fact, I'm an old Top Fuel guy. But here's the deal. What I saw back in my younger days and what they're doing today, apples and oranges, right? The loads that they're putting, and of course NHRA is, the binding parameters on these things. If they were to build the structure, it'd be a total different engine, right? So they have to stay within the constraints of the rules. I get it. But, listen, you cannot expect something that has a load of, let's call it 100 pounds, and I put 1,000 pounds on top of it and expect it to say, okay, it's going to have to yield. So don't think that balances are going to get you out of trouble there. It can't. But you should balance it within the scope of application because you want to take that variable out of the equation. To leave a variable in any math, the result is, oh, by the way, a variable.
Right.
It's not a constant.
And so it's not engine building as much as it is problem solving and removing, like you said, a variable.
Well, see, when I talk about Formula One, all right, that's under balance. But the guy said, okay, so they're doing it and they're getting away with it. These are smart guys. Well, hold on, apples and bananas. I mean, you're talking about an 18 to 20,000 RPM with a little piston like this and a short rod like that against this mountain motor like this and a rod like this. You shouldn't compare the two. It's a mistake, and I think it just sends you down rabbit holes. Now, if you want to pull it back a little bit and go back to the science of building engines, you'll see the answer pretty quick. This can only take X amount of load. End of story.
All right, we have done such a good job here that the questions have all been answered.
All right.
Let's do final thoughts as we wind down this session here by the 5500 and recap for people who are just, real quickly, who are just logged on. Bottom line is, saves time, reliable, you guys have training, and you update the data, the downloads for the program for people who are new to the unit.
Time is money. We agree with that?
Yes.
Okay. Now, the deal is I got people all over the country processing balancing applications. Some take an hour, some take 5 hours, but they charge almost the same. There's something wrong with that philosophy. So the technology we have here cuts to the chase. It takes a novice and turns him into an expert because all the mental gymnastics are back here. Now, if this doesn't take care of it, we're one phone call away to answer that unusual question. And there are some. You know, there's people that...
Example.
Okay, sure. Look, we got a situation where it's a 4-cylinder crank, and the guy calls me up and says, what kind of bob weight? There is no bob weight in a 4-cylinder. In fact, there's none on an inline. But you also want to understand that the engines have a unique property, not just first order balance, they also have a second order. And that is part of the structure of how the engine is built against the rod length and the rod stroke, right? So what happens is if his engine only did this, piece of cake. Doesn't happen like that. It goes around and gyrates, so it accelerates and decelerates and accelerates and decelerates within one rotation. That's the second order. As we change the rod length, as we sit there and we increase the stroke, it changes the total characteristic of the second order. This is why a lot of guys fall on that trouble of getting to overbalance, underbalance theory. They're going down rabbit holes, and they just need to understand the mechanical properties of what's going on. If they're confused, pick up the phone. We'll answer you.
And there you have it. And that's what it's all about. You definitely want to dive in on this, learn as much as you can, and of course, hit the website. We've got a lot more coming. Randy, tremendous information, and I think it's going to help a lot of people out there. And after all, that's what this is all about.
Again, Joe, thank you so much.
That's right. Hit the website. We've got more coming up. We've now done rotating assembly and engine balancing, but it's time to talk pistons, pins, clearances, and even more. And we're going to throw to our next video, so stick around. What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.